So welcome students. So in this question you're given that f of x is x times e power minus of 1 by mod x plus 1 by x if x is not equal to 0, 0 if x is equal to 0. You're asked to analyze the continuity and differentiability of this function at x is equal to 0. So first let us try to inquire about the continuity of this function. So if you see, this function involves a modulus, and modulus is differently defined in positive interval and negative interval. So I'll try to divide x not equal to 0 into two parts. So first f of x is equal to, now I'll take x less than 0 as one interval, x is equal to 0 as separate, and x greater than 0 as a separate interval. Now if x is less than 0, we know that mod x is equal to minus x. So this is minus 1 by x plus 1 by x is equal to 0. So x times e power 0 is x times 1, which is equal to x. That means f of x is equal to x when x is less than 0. Similarly, 0 if x is equal to 0. And what is the function if x is greater than 0? Mod x becomes equal to x. So you get x times e power 1 by x plus 1 by x is 2 by x. So you have minus 2 by x. So x times e power minus 2 by x if x is greater than 0. Now to understand the continuity of this function, let us find the left limit, let us find the right limit, and let us see whether both the limits are equal to the functional value. So limit x tends to 1 minus f of x is nothing but limit x tends to 1 minus f of x is x. Limit x tends to 0 minus. We're looking at x is equal to 0. So in the left neighborhood of 0, the function is x. So the limit is equal to 0. Similarly, limit x tends to 0 plus x e power minus 2 by x is equal to. So as x tends to 0, 2 by x. 2 by x tends to infinity. And e power minus infinity, this term tends to 0. This term also tends to 0. 0 into 0 is equal to 0. 0 into 0 is equal to 0. So now the right limit is 0, the left limit is 0, and the functional value is also equal to 0. Hence this function is continuous at x is equal to 0. Continuous at x is equal to 0. So now let us try to inquire about the differentiability of this function. So again, for differentiability also you have the same checking. So you have to find the left differentiation, you have to find the right differentiation. If both are same, then the function is differentiable. So what is the left differentiation? So f dash of 0, left limit is nothing but 1, right? The differentiation of x is 1. So the left side differentiation value is 1. What's the right differentiation value? For the right differentiation value, I just need to differentiate this. So I'll use the first principle. So the right differentiation is limit x tends to 0 plus f of x, limit x tends to 0 plus f of x minus f of 0 by x. That is x e power minus 2 by x minus f of 0 is 0 by x. So this x and this x gets cancelled. So limit x tends to 0 plus e power minus 2 by x. So 2 by x tends to infinity, minus 2 by x tends to minus infinity, e power minus infinity is 0. So the left limit is, the left differentiation is equal to 1, the right differentiation is equal to 0. Hence we say that this function is not differentiable at x is equal to 0. That means this function is continuous but not differentiable at x is equal to 0. Thank you.